Today we're using LlamaIndex to query a structured data source, and we gotta be making use of different LLMs, making use of LlamaIndex embedding capabilities, semantic search, and of course the ability to query structured data. Conceptually, we're going to be making use of the architecture that I called base plus reg in my previous video. Pieces of the puzzle are the prompt template, the sample questions with expected queries for future prompting, and then metadata from the database. With that being said, let's get started. This is the data model we're going to be working with today. There are customers, they purchase products from employees, and that purchase event is tracked in orders. And then there are vendors that supply products, and this vendor to product is a many-to-many resolver. So one vendor can supply multiple products, and one product can be supplied by multiple vendors. And then products belong to subcategories, and then subcategories make up categories. Now let me show you the exact same tables, but now in the Glue catalog and Athena interface. Glue lists databases. All of our tables sit right now in the main database. So these are the tables we just took a look at. Now, if we click through to one of these tables, you'll see that there are column names. They have data types, but they don't have any comments. For the purpose of this exercise, it will be helpful to add one of the comments so you better kind of understand how this fetching metadata from the database works. I'll edit the product number, and I'll just say something trivial. Uniquely identifies the product within an ERP system. Save. Okay, now we have one column with that comment. And now let's take a look at the same data, but from Athena interface. Same database main. Well, that's the query that I wrote earlier. Right, and now if we look at our products table, that's our products, that's our comment. And we can preview the data. Okay, looks good. So much for the data and the database. Now let's move on to actually querying the data with the LLM part. We'll be looking at the code that I extracted from all of these files, and they make up a Lambda function, and I explain how the Lambda function works together with a Bedrock agent in this video. Hope it popped up on the screen. But for this exercise, I just took the relevant code parts and put it all in one Jupyter notebook. So we'll be using that for the walkthrough. Let's start in the beginning. First, some basic imports. This is for connecting to AWS API. This is for connecting to Athena engine. All of these belong to LlamaIndex, and these are some prompt templates that I'll be looking at later on. Now, we're setting our logging to info, just because it's interesting to see what LlamaIndex deems to be informative. Now some basic variables, so the region, the bucket for our Athena, results, name of our Glue database that I showed you earlier. This is how the Athena connection URL looks like. Okay, now here we start making connections to I'll be using Bedrock LLMs for this tutorial. So here I'll be connecting to Bedrock, and I'll be using this model to do my embeddings. Right, and then this is the path to the few short examples. And this is the first piece of our structured data retrieval puzzle. Let's take a look at those examples. Here we go. This is the expected user input, and this is the query that we would ideally like our solution to generate. Here I only listed 3, but you can go crazy and list as many as you wish, especially for the edge cases in your data. Let's see what we have here. So total number of products supplied by each vendor. And I'll just show you that this is the working query. If I paste it in here, run it, we'll see the total number of products supplied from each vendor. Right, so that's our few short examples. And here the number of the few short examples that our solution will be picking for the final prompt based on the similarity, but more on that later. One important point to mention is that here we're declaring the embedding model, and that is because we're going to be making use of it multiple times throughout the tutorial, but not the model that will be building the actual SQL query. For that, we'll use a more powerful one from Anthropic, but I'm not declaring it here yet. Okay, so these are the variables. Now, just to show you how this embedding model works, we'll ask it to embed a simple string. That will do exactly that, producing the vector. Let's get rid of that for now. Okay, now the function that will be pulling the most relevant examples for us for future prompting. It's taking the user input, and then it goes into the few short examples and picks the most similar examples from this first column that are most similar to user input, and most similar as in a vector space. Right? And then it pulls n most similar examples. Here in our case, it's 2. So we go to the CSV, and then we read our examples in a kind of funny data structure where the key is the question, and then the value is the both question and the answer. So if you were to visually represent it, it would look like this. That's our data dictionary. There is question as a key, and then question and answer as a value. All right, so that's our data dictionary. And then text node is the basic structure of LlamaIndex. So we're creating text nodes out of questions. So out of the keys, okay? Now what happens next is we're creating this few short index where we're passing on our embed model, and the actual data upon which this vector store index is built is our few short nodes. So conceptually, that's our vector store index. It's just comprised of nodes, and each node is the question from our dynamic examples. That's our few short index, and then few short retriever is just construction on top of this vector store index, where we also say how many examples should be pulled based on the similarity. Again, because this is for demonstration purposes, I really lumped a couple of functions together, so don't judge the design, please. Okay, and now once we've done that, we now want to retrieve the most similar questions and answers. And that's how we do it. We say, okay, so from few short retriever, retrieve the relevant examples for a given user input. Right? And then it just does formatting. So once again, what we're doing in this function is our dynamic example CSV. And then we generate kind of 2 data structures. One, the data dictionary, where the key is the question and then value is question answer. And then this few short retriever vector store index. And then we compare the user input to each of these nodes. And let's say node Q1 and Q3 were deemed to be most similar to our user question. Then it will take using this dictionary, basically, and go and pull these two values for our few-shot prompting, and then these two values for our few-shot prompting. And all of that is done in here. Okay, so that's that. We're declaring our function. Now we're getting to retrieving the database schema. All simple here. So this is the SQL engine connecting to Athena, making use of that connection string we declared earlier. This is an abstraction upon basically our connection that comes from LlamaIndex, the SQL database. Now we're making this list of our tables, and in that list, each table represented was kind of two attributes: the name and then so-called context string. And then where we're taking that context string, one of the helper files that we're using is this prompt template. And in there, for each table, we have a chance to additionally specify some detail. So on top of what's available in our database. So here I did that for every single table. And exactly these strings are then being pulled in here. Okay, so here's just a list of tables. And we're already using this SQL database object to iterate over tables. And then, very similar to this few-shot examples, we're making one more time kind of vector store index, but this time with the wrapper of the SQL table node mapping, where there is a node object for each table. So this is where we actually created this final vector store index from the database nodes, and we're passing this mapper construct here, a list of our tables. We're saying that it should be a vector store index, and then we're passing on the bed model one more time. So it will be judging how similar the user input is to each of the kind of table details that it will be able to pull from the database. Unfortunately, LlamaIndex doesn't provide kind of good way to show you kind of the structure, the underlying kind of structure of these objects along with all the attributes. So we'll skip that for now, but later I'll show you how exactly that metadata looks like once it reaches the LLM. Okay, so we have that. And now the final part, putting all the pieces together, that's our user input. That's our prompt template. It's coming from that file that I just showed you, SQL template string. So that's our initial prompt. Basically a lot of boilerplate saying that it should generate a SQL query and the format it should follow. Then this is the placeholder where we'll insert the metadata from the database. Basically all the table definitions and schemas. And this is the placeholder where we'll insert our few-shot examples, like those two few-shot examples that were most similar. And this is where the actual user question will go. And then we'll expect it to produce a SQL query. So that's kind of the form. Okay, so that's our template. And then we say, okay, this should be replaced with whatever that get few-shot examples function generates. Okay, let's run these through. Now, this is the actual LLM we'll be making use of for generating queries. And that's Claude 3. Upon the time of recording, Claude 3.5 is already out, but somehow wasn't able to make it available for my account. So here we are with Claude 3. And that's where we create this query engine. So this is the engine that will be generating the SQLs based on the user input, running them against the database and basically producing the results. Let's declare that. And now we can start making use of this engine. So we'll pass on this user input. Okay, this is interesting. This is the info logging that is coming from LlamaIndex, and you can already see that it, for some reason, decided to output the metadata that it pulled from Glue. For example, if you look at the products table, products has columns and then describes the columns along with their types. And remember, we gave a comment to the product number column. So here is our comment. And then that short description that we also provided in the file comes here as well. So it's all kind of lumped together. Okay, another important point to note is that here it's also logging the examples that it decided are the most similar to the user input. Let's see which two it chose. Once again, our user input was what's the most ordered product, and it decided that these two, so the total number of products supplied by each vendor and list all products along with their category and subcategory names, are the most fitting. And that's the output. Then the response itself looks kind of funny. All of it is in here, along with kind of like result, some metadata, so the query it used to kind of produce it. So we can, and the string representation of this is just the actual output. But for example, if we wanted to make use of the actual query for whatever other reasons, we can also access that. And one more thing that I would like to show you are the actual logs of accessing the large language model. I'm using AWS, and that's why all of the foundation model invocations are logged in CloudWatch. I had to enable that. Maybe I'll just do a very short video on the importance of doing that as well. Log groups. That's all the calls to the foundation models. Let's expand this one. So this is interesting because here we're making use of the embedding model, and that's the call to the embedding model to embed the user question. Then you can see also embedding calls for other pieces of our puzzle as well. So I guess this is right. That's one of the examples provided in here, right? That's our call to embed all of this. Okay, this is our final prompt. This is some of that boilerplate prompt template. Then the table schemas that it decided are relevant for answering our question. And then here are some useful examples. So basically pretty much what you saw in the LlamaIndex output. And then here's the question. And then you see that the response from the model for that was the actual SQL query along with the SQL result. Now, I guess one more thing that I forgot to mention here when creating this query engine, there's an argument called response synthesis prompt. So that's yet another prompt template that we make use of to kind of convert the raw results, or like the raw output of our query, to something more human readable. So basically, if we go and take this query that it may use to generate the results and run it, right, it will only give us that much. But somehow it was able from this result to generate this response. And this is exactly what this response synthesis prompt is doing. Right, and that's also what we see in this last call to the LLM. That's our response synthesis prompt. And then this is the very, 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 very final response that we get. And this is what we see as an output in here as well. That's it. That was a lot to kind of unpack. I'm pretty sure I missed a bunch of important things that I wanted to say. But hey, let me know what you think. Hope it was helpful and have a great day.